Hey guys, welcome to Coding Science. I guess you wonder what a stack is. Well, today this is a full course on the stack. First, we'll take a look at the concept. So we won't go much in the details, we just try to understand how it works. Then, in the second part, we'll take a look at the data structure, which means what variables we have and what methods are associated with the stack. Then in a third part, we will implement those methods in pseudocode so we can try later to implement them in any kind of programming language that we want. So let's get started. Okay, so let's start. And what is a stack? We'll go through the concept, but first a small definition. A stack is a container of objects following the last in first out principle, also called LIFO. It is possible to insert objects at any time, but only the latest inserted can be retrieved at any time. So what does that mean exactly? I mean, short enough, but let's take a look at it with some visualization. So we have here a box. I'll show you here. We have a box that will represent our stack, and we get some objects that we'll put in and retrieve. We'll collect our actions here so we can remember what we've done. And here we will make a sequence of the result when we retrieve things from the stack. We'll start with filling up the stack and then emptying it completely, just to see the main idea how it works. And then we'll see another example. So let's start. We start by pushing some elements, 5 elements actually. The first element is 1, and the latest element is -2. It's the last element that we put in. So now let's pop them out and see who comes out first. So we're going to do the pop function, which is the word used for retrieving elements, and push is the word used for putting things in the stack. And as you can see here, the first element that came out is -2. It was the last element we put in the stack, and it became the first one coming out. Then it went to 5, 7, 3, and 1. So simple enough. So that was an example of filling it and then emptying it. But what happens if you wish to, let's say, push some elements and then pop some, and then push again, and then pop again, and so forth? Most programs will do something like that. So let's see how it behaves then. So we start from fresh, and let's push some elements. We push 1 and 7. Okay, so the latest element here is 7. So now let's pop an element. 7 comes out. Now let's push some more elements. 3, 12, and 5. Let's pop some. That 5 comes out again, first because it was the latest inserted, and then 12. That was just before 5. Now let's insert the rest, or push the rest. There we go, the stack is full again, and now let's empty it. There we go. So as you can see here, we got a sequence starting with 7, because it was the last element inserted at the moment of the pop. Then we inserted 3, 12, and 5. And at that time, the last element inserted was 5. So when we popped, we got 5. So 7 and 5. then it was 12 because we popped again, so we have a 12 here. So 7, 5, and 12, and so forth. It's not complicated, but it's important to remember, because when you're using stacks, that's something to take in account. Depending on the timing of your pushing and popping, you'll get different sequences. Well, that's it for the concept, but let's take a closer look at the class structure that can be used to make a simple array stack, as well as some pseudocode for all the methods associated with the stack. Now, let's think a little bit. What do we need? So to make a stack, and this will be something that we call a simple array stack. So what we need is to start is an array, something that we can, a container where we can keep the objects that we try to stack together. Now let's make an array. In this case, we'll work with integers. So this array that we call S will be an array of integers. But we also know, for those that have worked a bit with programming before, that simple arrays and normal arrays, they need to have a predefined size. They're not dynamic. They don't change size over time depending if there are more elements coming. It's just they have a specific number of cells where you can put stuff in, and they will stay that size. You don't need to fill them in, but you can never put more than what you define. So we will need also a variable that we will call n, that represent the size, the number of elements that you will allow in your array. I just want to make sure that people understand that this is not the index or the pointer. It's not the variable that will tell you in which cell you're going to go into the stack. This is just the number of cells. And this is for a specific reason, is because we can't use the same for both the pointer and the amount, because let's say that you have an array with 10 cells, the n will be equal to 10. But as you must know, maybe, arrays have pointers from 0 up to the number n. So it means that you start at 0, and then the last index for the array would be then 9, not 10, 9. 10 is excluded, because if you count the numbers of cells from 0 up to 9, you have 10 cells. So that's important to remember. So now this is just the size of the array, but we'll need it in the functions. You will see, both to start to initialize the array, but also because we're going to use some checks around it later. Now we also need a pointer that we'll call p. The pointer is also an integer. Both of them are integers. And this pointer will keep track of which element in the stack is the latest element inserted. So this one will be moving up and down depending if you push things or pop things. And we'll take a look at this closer later. As you can see, it's been initialized to -1. It's not, the others haven't been initialized, they're just empty. But this one will be initialized at -1. It will always start, when you create your stack, it will always start at -1. And there is a specific reason for that, and I'll talk a little bit about that on the next step. So we have our variables. Next to that, what we need when we make a class, because this will actually become a class in a programming language, what we will need is a constructor. So this is not a constructor specific to any kind of class. I mean, most of them are written that way somehow, but this is just to represent what kind of information we will need in the constructor. So we can see here, for example, that we'll call this constructor stack with a big S. and it will take in what's in parentheses here is the parameters that are taking in. It will take in an integer, and it will be the number n. So when you initialize your stack, you will have to write either 10 or any kind of numbers that you wish to have to know the number of cells you want in your stack. The parameter, the constructor will not return anything, so we'll have a void here, and it needs to be public so that it can be accessed from outside of the class. And then we'll need some methods because we have to do stuff with our stack. So we'll have the first method, that is the push method. We've seen it earlier. The push method is to add objects to push objects in our stack. So since we're working with integers here, this one will take also in integers, and it will be called, the variable will be called O. If you were making a stack of other kind of objects, this int here would be replaced by something else. But today in our example, we'll use integers. The function or the method, is not going to return anything. So here we'll have void also. Void means that it does not return anything. There is no result to get from that method. And it also needs to be public, so we can access it from outside of the class. The next function that we have here is the pop function. It's the two main functions of the stack. Pop here, as you can see, has no parameters because pop is to retrieve the latest inserted element. You can't choose what you're going to pop. It will always be the latest inserted element. But since we are retrieving something this time, we'll have an int here because we're working with integers. So we'll retrieve the latest int that has been inserted in the stack. And it also has to be public because we want to access it from outside the class. Now there is another function that is interesting. It's very similar to pop. It's called peek. Now peek, to understand it, it's the same as pop, but it's like a box and there is something in it. Pop, you would open the box, take it out, and see what it is. Then the object would be in your hand, you would see what it is, but it's out of the box. Now peek is exactly what it does. You would open the box, look at it, see what it is, but you don't remove it from the box. So that's pretty much what we're doing. With peek, we are looking at the value, the latest inserted value, but we're not removing it from the stack. So we get an integer here, we'll get the integer, we'll get the value, but will not remove it from the stack. So if you do peek 3 times in a row, you get 3 times the same value in a row. And it also will be a public function. The next two functions we'll see, there are kind of check functions. So the first one is empty. This one will be returning a Boolean value. For those that don't know, a Boolean value is a 0 or a 1 or a false or a true. So we use 1 for true and 0 for false. And the function is empty, then will return you true if your stack is completely empty. So here it means if p, we'll talk a little bit more in the example why, but if p is -1, so if p is empty, if the stack has no object in it, then it will give you the true value true or 1. Now, if there is even one element in your stack, the isEmpty function will give you false or 0. The next function is kind of the opposite. It's the isFull function. So now its full function, it will give you true if there is no more space in your stack. We talked about that arrays, they're not flexible. If you get an array of 10 elements, there is 10 elements, you cannot put 11. Well, with that, and if you would try to put an 11th element, you would get an error, a crash, or yeah, it would get some trouble in your program. So the isFull function allows you to check if you have more space. And so if there is no more space, it will give you a true, so a 1. But if the isFull, if the stack is not full, if you still have at least one place available, one place that is empty, one box that is empty, then it will return you a false Boolean value, also also 0, either 0. And also this one will be public. That's pretty much the structure of the stack. So now let's take a look at the algorithm with pseudocode. Let's take a look at the algorithm for the function push. So here is the algorithm push. And we'll try to make a drawing here to make it more understandable. It's not very complicated. You see there is 4 lines. It's not the most complex algorithm, but it's nice to go step by step and see what's happening. So we start by using the push function and putting an object. So we'll need the O object here, that is here. That will be that box. Next, we'll need a representation of our stack with the variable n, p, and the stack itself s. But as you can see, the stack itself, it has actually, depending on the n number here, will have different size. So we'll first decide how big we're going to have our stack, how many cells we're going to have, and we'll decide for 5. Then we'll initialize our p to -1. There we go. And I will explain in a second why. And we'll create our stack, our array that we call S. It's an integer, it's an array of integers, and it has 5 elements. 1, 2, 3, 4, 5. And as you can see here, the array, first element of the array has an index here of 0. That works itself up to 4. Now, this is the reason why we start p at -1. I remind you that p is the pointer. We represent it here. It's the pointer that will point at which cell is the latest element in the stack. But if p was pointing on 0, just standard, then you wouldn't know if 0 is empty or not, right? Because if p is on 0 from the start, then you don't know if there is anything in here. Because even if it's empty, it's still on 0. And if it's full, it's still on 0. So that is a problem for us. We need a way to know if the stack is empty or if the stack is not empty. And that is why we start p at -1 here. And then we'll need some elements. We'll make a connection to show here. And then we'll have some elements. There we go. So now we're ready to start playing a little bit with the function, with the method. Keep mixing those two. So let's see. We'll start with the 2 here. So we'll use the function, the method push on the integer 2. So O here will take the value 2. Okay. So now we've done this part. We'll go to the next. We do a check. If p plus 1 is equal to n, then we maybe do something. So p plus 1. P is at -1 at the moment. We'll add 1, that becomes 0. Now n has the value 5. 0 is not equal to 5. Then we will ignore that line completely and we'll jump to that line. So here, first, we'll attack it from that side. Usually you work that way around. So p plus 1. So we haven't changed the value of 0. I mean, this here, we just did a check. We haven't changed the value of p. So p is still at -1. So p plus 1 is 0. Now, this arrow here means that in pseudocode, this arrow means that we will put this value, the value of p plus 1, into p. So -1 plus 1, 0, we'll put that 0 into p. So we'll replace it with a 0. Okay. So now the p value is at 0, so the pointer now points at 0 here. Doesn't point at -1 anymore, it points at 0. This is important. The O object, which is this one, with the value 2, there is the arrow again. So we'll put the value in O into the array S at the position P. The position P here is 0. That is the array, that's the position 0. So we'll need to put the value in O, which is 2, into that position. There we go. And now we're finished. We've done the algorithm for the push function. So now we use return. That means that we exit the method. So we're done with 2. Now let's use another number to see it again a bit faster maybe, but let's use another number. So now we'll use the push method again on 6. So O, which is here, becomes 6. Okay. So now we're going to check p plus 1, is it equal to n? Well, p is equal 0 now, not -1. It's equal 0. Plus 1, this is 1. 1 is still not equal to 5. Fine. Then we will ignore this line and we'll jump directly to this line. So p plus 1, 0 plus 1 is 1. Then we will put that value 1 into p. Let's do it. There we go. Fine. So p has now the value 1. So it will jump up to the element in the stack here. Okay, next line. Now we take O, the value in O, and we will put it in the stack S, the array S, or I call it the stack, but it's actually the integer array S, at the position P. P is 1, we see the pointer here. Then we will put 6 in here. There we go. So now we have stacked it up. And as you can see, P is pointing on the latest element of the stack. So we're finished and we return. And we'll do this for 3 more numbers. So we'll fill it in like that. And it's the same process. We change P every time and we'll check it. But I want to show you, because it's no point in doing this 5 times, but I want to show you what happens when the stack is full. So now we are in the situation where P is in position 4. You can see here P is equal to 4. And we still have a number here. So we have -2. And let's say that we didn't put any checks. We didn't use any if empty function or is full function. We didn't use is full, so we didn't check if it's full. So we are trying to push a number when our stack is full. So let's do this. We push the number -2, the integer -2, into our stack. So where we go? O takes the value -2. Fine. So now we do our check. If p plus 1 is equal to n, so p is 4 plus 1 is 5, and this time it is equal to n, which is 5. So 5 equals 5, that is very true. So what now? Well, we'll do this here, this line here. So you see the line has a return. That means that this will not be executed. We will, after doing this, we will actually exit the method. So this will not be done, and there will be no changes done to the stack. Okay? This part here, a stack full error, that's dependent on how you handle your errors and how you program your software, and also what kind of language you're using. So this, we're not putting any details in it. It's just you will generate. If this would happen, it should generate an error that would be handled by your program. Or just You can just make a print saying there is an error, blah, blah, blah. But the important part is that nothing happens to the stack. You didn't do any changes, okay? Because if you were, for example, that you put this after this, then suddenly the -2 may have come to here, or you would crash, or there's many unforeseen result that can happen. That is why this is here. It's to stop the program, is to stop the algorithm before you're going out of your array. So yeah, that's pretty much the important part. And then you would return and nothing would happen. So -2 comes into O, but it doesn't do anything. So that's it for the push method. Let's take a look now at the pop method. Here is the algorithm. Not very complicated. There is a few changes though. We won't be working with values that we put in. We start with a stack that is already full. We won't use the variable O, but we'll use a new variable that is E. E will be the result, and we will return them in a sequence that we'll see here under when we're returning the values from E. So let's start with the first element. So we start on top because it's the latest element that has been push into the stack. P is at 4, so we're here. The first thing we do is to check if P is inferior to 0. In this case it's not, it's 4. So we will ignore the error and we'll just go to the next step. Now, as we've seen, this take the value in S at the position P. So here 4, this is 9, and it will put it in E. There we go. The next step is to take that cell in S at position P, and we're gonna put a null value in it. It's not a 0, it is null. In programming in integers, with integers, 0 is not a null value, it is 0, it's a number. And we don't want a number here, we want it to be cleared, completely cleared. So we will remove the 9, it's still in E, but it's not anymore in here. So by doing this, we are completely removing this value. Then the next step is going to update the P. So we'll take P minus 1 and we'll put that in P. So 4 minus 1 will become 3. And now we are finished. We will return E and get our first sequence. There we go. Our first number in our sequence. And P has moved down to 3. Now, if we were going to do that again, this function pop, we would get the same result. And now -5 would become extracted here, and P would be 2. We will retract 1. So we'll do the same. So that's fine. But what if we are in a position now, we have one last element. All the elements have been extracted with pops. And now we are in with the last element. What happens then? So let's do this. We first check if P is inferior to 0. Well, it's not. It is equal to 0. So the error is not generated. The value S is put in E, as we see here. Then we will put a null in the position 0, because we're at 0 here. It will be clear. And then the pointer that is pointing on 0, we will subtract 1 and put that value in P. So it will be -1. Then the pointer jumps down outside of the array. So now we didn't get any error. We emptied our stack. But what if we are trying to pop again, what would happen then? Well, P is now inferior to 0. We would generate an error. Like I said with the push method, this can be handled differently, different ways. But the important part is that the return happens here. So this part will not happen. Okay, we won't try to extract a value from E because we are outside of the array. It wouldn't work. That would generate also an error. And there is nothing to nullify, and P won't change any value. So we're not doing that part. And you wouldn't get any result in here. So that's pretty much it. Now let's take a look at the peek method. Here is the algorithm. And we'll take a walkthrough into what it does. Now, we set up in this, we go back a step backwards, and we come back to the last element. This will work in any elements. If you have 1, 2, 3, 4, 5, doesn't matter. Just use an example here. So now P is in position 2, position 0, sorry, and the number 2 in here. So let's use the function peek. We call peek, does not take any parameters, and we just should give back the last item that has been stacked. And in this case, this is this one. So let's see. First, we check if P is inferior to 0, then we may do some error, return an error, but in this case, P is equal to 0, not inferior. So we'll skip that line and go directly to that line. Here we take the value from the array S at the position P, which here is the value 2, and we'll put it into the variable E. There we go. And then we will return E. So we get in our sequence of results, we'll get the number 2 here. But what if we do it again and we peek again? What would happen then? Well, as you see in here, we didn't do any changes to P. We didn't subtract 1 from P, so it's still at 0. And we didn't nullify the 2 number in the position 0. So if we do it again, we get the same result, and we get a second number 2 here. So our sequence simply has 2 number 2s, one after the other. So that's the main difference with the peek function compared to the pop function. It retrieves a number. It gives you the number without deleting it. So now, what if we are in this situation where the array is actually empty and P is equal to -1? So let's see. We call our function peek, or a method peek. If P is inferior to 0, then in this case it is inferior to 0, it's -1. So we return an error, and since we return here, this part here will not be done. It will be ignored. So now we just pop out of the method and we finish it. We do not collect any sequence, any number for our sequence. But we do generate an error that needs to be handled in your program when happens. That situation here in peek and pop and stack, we always have some possible errors if we try to either add an element when the array is full, or when we try to pop an element or peek an element when the array is empty. that generates error. That is why there are two more methods that we'll see in a moment to help us beforehand. We can try to see if the stack is either empty or full, so we avoid those errors. So the first function we see now is the empty method that I remember is supposed to show you, to give you an idea if your stack is empty or not. So here is the algorithm. It's a very simple algorithm. We are now in a situation where we have a stack that is not empty. We still have a value in it. So let's call our function. We call the isEmpty function method. So if p, well, now we're using p to see if we are empty or not. We're not checking any values. We don't go through the array, because p is always on top of everything. So if p is not negative, I mean it's not inferior to 0, then if it is, then it's true. But if it's not, then we go directly to the else here. We can see p is equal to 0, and then we put the false value into e here. Now I put false here in many in actual, when you would program and get a Boolean value, you would get a 0. We generate a 0 value here, a false value, and we get a sequence Boolean false. Okay. But now, what if we are in this situation where where the stack is empty and p is equal to -1? Then suddenly the if here becomes true. And then we will come to that point where e will be filled with the value true, and we will return a true value. Very simple algorithm. It's just, it allows you to know if your stack is empty or not using p. And then we have the kind of opposite, which is the isFull function or isFull method, that's supposed to show you if the stack is full. So this is a situation where we are on almost full but not full array. P is the value 3. So let's try to call the full function. We call it, and then if p now, the check we do is still on p. Again, we're using p to see if we're empty or not. So p, if p is inferior to n-1, n is the number of elements, but we want to know if it's inferior to the maximum index, to the highest index in the stack, and the highest index is always n-1, because we have like we talked earlier, we start in 0 and we add 5 elements. It becomes 0, 1, 2, 3, 4. And in every situation that you will have, if your number here is 1000, then your last number here will be 999. So you always end up with having to check if p is inferior to n-1, which is in this case 4. So let's see our situation here. P is equal to 3. It is actually inferior to 4. Then we jump to that line here and we add false into our e variable. The else will be skipped, because when you have an if else, you always do one of those, not both. So the if was true, we did this one, so this will be ignored, and we'll be jumping directly to the return of e, and we will get a false Boolean value from the method. But let's see, if we are in a situation where the stack is actually full, and now p has the value 4, then suddenly this one, and this if check here, p inferior to n-1, is not true anymore, because 4 is not inferior to 4. Then we come to the else part. We ignore this and we go to the else part. And now e takes the value true and we return it. And we get now the value true. And again, this method is very useful if you want to try and add something to the stack, but you don't know where you are. So you wonder, is there space into my stack to add something? So you call the function isFull that works very well with the if not true, then you would be able to add an element to the stack. Or you could say if isFull equals to 0. Then you could add a value. If you're sure that it's equal to 0, it's equal to false. So that's why it's important with the isFull function and this empty function. They help you avoiding the errors from the pop function, push function, and peek function. Because in the end, we want to make some programs that do not generate errors all the time. So there, we've been through the concept first, then the data structure, what is needed to build a stack, and we've gone through all the pseudocodes of all the functions that are useful for a stack, and you can apply this to any kind of languages. Okay, so you could make it in Python or Java, whatever. This is the concept is true in any languages. Okay, that's it, guys. This course is finished. So I hope you learned something, and if you like the video, please give it a thumbs up. If you're interested in any more tutorials or videos about programming or data structure, I will publish more. So please subscribe, and I hope you enjoyed.